Afternoon, good morning. Welcome to the joint seminar of Asian Demographic Research Institute at Shanghai University and the Asian MetaCentre for Population and Sustainable Development Analysis. Today, we are extremely delighted to have Professor Wolfgang Lutz to speak on the power of multidimensional demographic model for understanding sustainable development priorities. Professor Lutz doesn't need any introduction. Nevertheless, I would like to emphasize that Wolfgang helps and chairs its International Scientific Advisory Board. He is also the architect and one of the principal investigators of Asian MetaCentre. His support and guidance for Asian population research communities is invaluable and highly appreciated. I also want to highlight Wolfgang's position as the foremost leader in multidisciplinary research on population and well-being. In the words of Joe Cohen, Wolfgang Lutz secured his place among the handful of the world's most influential demographers by decades of pioneering empirical research, theoretical exploration, and institutional leadership. Wolfgang has evidentially demonstrated that demography has the scientific rigor to offer predictive power for social change and human welfare. I'm now sitting in Wolfgang's office at IASA after attending the Scenario Forum organized by the climate change research communities. Demographers have made critical contributions to developing the narrative and quantitative core elements of climate change scenarios based on demographic methods, especially the multidimensional demographic model. How was that accomplished? Professor Lutz is going to tell you soon. Now, without further ado, let me turn to him. Wolfgang, the screen is now yours.
Good morning and good afternoon, depending where you are sitting. I'm delighted to be with you today. Thank you first, Levin, for these kind introductory remarks. I will now try to share my screen. I hope you can see it.
Yeah, we can see.
Full screen mode. Yes. Okay, what I try to do this time, I'm going to speak about maybe 45 to 50 minutes about what I find quite exciting, namely that demography as a discipline becomes much more powerful and much more influential and also meaningful in a way through its multidimensional approach. You will see in a few minutes what I mean by this. Essentially, it is not only looking at the age and sex structure of the population, but also considering the changing structure and changing dynamics of other demographic dimensions. And I will illustrate this also with pointing at the role that demography can take in the setting of sustainable development priorities. So what we're going to do today is first have a look at demographic theories and multidimensional demography. Rarely in demography we hear about theories. Demographers are proud to have lots of data and tools, powerful methods for analyzing this data. But any self-respecting discipline also needs a body of theories. And I will talk about 3 demographic theories that I will explain you. And then we go into some empirical work, some illustrations of the population by age, sex, and level of educational attainment, as we have reconstructed them back to 1950 and projected by different scenarios up to 2100, as they are given in the Wittgenstein Center Data Explorer. And in the last part, I will talk about how multidimensional demography makes our discipline more relevant for the rest of the world. So this is, I think it makes demography better for its own sake, this multidimensional approach, but it also makes it much more useful and more relevant for the rest of the world. So maybe we just step back and say, like, what is demography? Well, there is a classic definition of the discipline of demography. It used to be on the IUSSP website for long, and it's also in many of the standard textbook. It is the scientific study of changing population size and structures. So it is important to say here that structures is in the plural. So we are not only talking about age structure, but we are talking about multiple structures. So what structures does multidimensional demography look at? Of course, there is age and sex. Much of the demographic methods that we are using are based on age and sex. And in particular, one of the strengths of demography is that age and time, they go on in equal steps. So we can all do this conversion from cohort to period analysis and so on. Place of residence has always been an important variable, not least because the history of demography is based on national population analysis. So, and then we have urban and rural place of residence or by province. So where people were born also, but more importantly, even where they live now is one demographic dimension. And then education, educational attainment, the highest level of educational attainment has always been a key component in demographic data collection. Often labor force participation is being collected. Ethnicity, that's what we call it in Europe, or race in the US. So what variables are we looking at? We are saying at the famous textbook by Schreyer and Siegel puts it, we're looking at demographic variables, characteristics, or dimensions, as we call them, as they are traditionally collected in censuses. Or if there are some surveys that are sort of not for a demographic purpose, it could be, I don't know, some consumer spending surveys. There always is a box at the beginning that says demographics, where they want to get some basic characteristics of these people. And that's exactly where they ask for age, gender, place of residence, education, and so on. Now, there is another thing when we try to define what demography is. By its very origin and also by the term demos, we are looking at the aggregate. Demos is the Greek word for population. It's not an individual. Actually, the Greek have another word, idiotes, that's the individual citizen. And actually, the word idiot that we use these days is derived from this. An idiot is someone who only looks in his own affairs, only in his own interest. And if you're interested in the aggregate in society, then you look at the demos. But of course, we cannot understand the changes at the population level, at the level of the demos, unless we also have a look at the micro foundations of, let's say, fertility behavior, health-related behavior, migration behavior. So in this context, I find this famous Coleman ship, as it is depicted here, quite helpful, where it shows that what we are in the end interested in demography is the macro level outcomes. You see it on the upper right corner, which is partly caused by macro level conditions, but these macro conditions also influence the micro conditions that lead to micro outcomes. So when the micro conditions are, when, for instance, a couple are deciding whether they should have another child or not, they make this, they experience micro conditions, and then they make a micro demographic choice to have another child. And then it's being aggregated up, the sum of all such choices then results in a birth rate. So it's important that also, I think that demography in its very origin and its main orientation focuses on the macro level. Of course, there are many, many studies, and actually if you go to PAA or any population conference, or you look at the dissertations written in demography, a huge proportion of them looks at micro levels. So that is also needed. Now, what is a demographic theory? With demography defined as studying the changing size and structures, this adjective demographic in the strict sense should only be applied to theories that try to predict aggregate level changes. Now, we can talk about, I will talk then about the specific theories. Here, just another word. that as Karl Popper, the philosopher of science, made quite clear in his view of what is a theory, that only things that have predictive power can be called theories, because only those can be falsified. If you just make some vague statements that do not have predictive power, some people may call this a theory, but in the strict sense, I would not call this a theory, because a theory needs to have predictive power, and a demographic theory predictive power at the aggregate level. So I identified three demographic theories. The other two sound probably very familiar to you: demographic transition and demographic dividend. I say only a few words. I will say a bit more about the theory of demographic metabolism, because it is probably new to you. At least this term is new to you. So I will talk about the origin. Actually, the term was coined by the American demographer Norman Ryder already in 1965, and I'll explain you a little more. And I should also say there is, of course, a multitude of theories relating to individual behavior. We talk about fertility theories, mortality theories. And again, they are very important for understanding the micro foundations of demographic trends, explaining and predicting components of demographic change, but they only focus on one aspect, one part, and not the overall population size and structures. So I would call them partial demographic theories. And full demographic theories are only the ones who really look at the aggregate change as it results from all factors, all components working together. At this point, I should have a little advertisement for this book, Advanced Introduction to Demography. It's actually a rather thin booklet that I was invited to write during the Corona lockdown. So it came out last year, which tries to summarize much of what I'm saying today, including these demographic theories. There's a long chapter on demographic theories in this Advanced Introduction to Demography. So if you want to follow up, it's actually quite inexpensive. I think the paperback version is some $20 or so. Now let's move to what this theory of demographic metabolism is. It's been comprehensively described in a paper I did in 2013 in Population and Development Review called Demographic Metabolism, a Predictive Theory of Socioeconomic Change. So it's not only demographic change, but it is predicting societal change. And it's not a theory, as I said, predicting individual behavior, but rather predicting aggregate level change. So in a general theory of how societies change, as a consequence of the changing composition of its members with respect to certain relevant and measurable characteristics. And these characteristics can either change over the life course of people, that's what we call an age effect, or from one generation to the next, that's what we call a cohort or a generational effect. Now, this idea is not new. If we go back in the history of sociology, there has been a German sociologist, Karl Mannheim, who in 1927 wrote an influential essay on the problem of generations. Although it was written in the 20s, it only in the 1950s got translated into English. So Mannheim has sort of two different views of generations. The one is what he calls a positivist one. It has a biological perspective, and I think we can call it a demographic. That is sort of the cohort replacement in the way we understand it in demography. But then he was also influenced by the historians, particularly the art historians, talking about what is called the entelechy, a Greek word for giving the inner spirit of a generation. You find a bit of this in marketing when you talk about the baby boom generation and then generation X or Y and the millennial. It's that their generations have some sort of in common. They have a sort of an inner spirit, how they are different from others. And in here, he really took the art history as an example. So if you walk through a museum, you in one room, you have a certain style of painting, and then you go to the next room, then you had a new generation, another generation of painters painting in another style. So this is how the evolution of painting is driven really by new cohorts of artists coming in. And then there is, of course, Norman Ryder, and he has written in 1965 this hugely influential paper in the American Sociological Review called "The Cohort as a Concept in the Study of Social Change." So in this paper, and it's a long paper, but mostly people focus on the first part of it, where he gives the standard definition of what a cohort is. And I think every student of demography around the world these days has to learn this definition, that a cohort may be defined as the aggregate of individuals within some population definition who experience the same event within the same period. And typically we're looking at initiating events like birth cohorts, or the people born in the same year or the same period more generally belong to a cohort, birth cohort, but we can also define marriage cohorts as those who married in the same year. So it's a common experience. And then in the second part of his paper, he introduces this notion of demographic metabolism as the massive process of personnel replacement driven by the birth, lives, and deaths of individuals. I should say a word about metabolism. It is another Greek word, and that means essentially transformation. It is mostly used in biology when sort of we have a food intake, we eat and drink, and then our body derives the energy from this, and then through the excrements we abolish some of the parts that we don't need, but it has been a complete transformation of these calories into energy. Now, this is used in many different, more theoretical contexts. People sometimes talk also about social metabolism, or like environmental metabolism, or how societies use environmental goods and materials, transform them, and then deposit what is not needed. So that is the definition as Norman Ryder gave it. Ryder himself thought that actually the cohort change, the cohort replacement, is the only important way through which societies change. He explicitly said in his paper that societies whose members were immortal would resemble a stagnant pond. So there would be no change if people would be living forever and no new members would be coming. And this is, of course, a bit extreme. We know that people can also change, and there still is some learning and changing over the life course. And also it's important to say that metabolism may make change likely and possible, but it does not guarantee progress to the beneficial. You can also have sort of the coming young generations you bringing things into a worse direction of whatever our criteria are. So how does the theory of demographic metabolism, as I introduced it in the 2013, differ from Mannheim and Ryder? A big difference is that the theory focuses on heterogeneous generations. So people of any given cohort has distinguishable characteristics. Like even in a given birth cohort, you have different education categories, or by language or national identity or whatever, even social categories you want to study. And unlike Ryder, this theory does not require complete cohort determinism. Under the demographic multi-state model, people can change over their life course from one state to another. So as we can combine from a lower education status to a higher education status, or for being out of the labor force, in the labor force, and then out of the labor force again. So there are transitions over the life course. That's what demographers like to model a lot. But then on top of this, there is the cohort replacement. So these two forces, they work together. And with multi-state models, we can really combine their joint effect. Interesting is that neither Mannheim nor Ryder, who Ryder was a mathematical demographer after all, used this for forecasting, for making statements about the future. Now let's illustrate this a bit, what it means. So here we have Republic of Korea, South Korea, some data in 20-year steps. You all know, of course, the age pyramids with the women to the right, men to the left, and then sorted by age. And then we added a third dimension, which in this case is education. So red means no education, never been to school. Yellow is primary, then secondary, and the dark blue is tertiary. Actually, this comes from a paper that I've done with Raya Mutarak in Nature Climate Change, where we show that this is a very helpful model for also forecasting the societies of the future, which will be able or not able, depending on how the society will be, to cope with future climate change. So this is already sort of shown for the outside world, outside demography. But here it illustrates it, that's what I took it, that it is sort of quite clear. We have like 1970 is the first age pyramid, and you see in 1970 South Korea was really not so highly educated, and particularly the women above the age of 30, they are essentially all in red. They have not had the opportunity to go to school because in the 40s and 50s, Korea really was still an extremely poor developing country. But then in the 60s, the schooling started to expand. We'll look at this a little later. But then in 1990, 20 years later, this cohort is 20 years older. You see then between 15 and 30, they still gain a little more education. You have some dark blue added here. But after that, after your early 30s, typically people have completed their education. But then again, 20 years later in 2010, the same cohort is 20 years older. And you know the educational distribution of that cohort, you only have to adjust for differential mortality and migration happening over these 20 years. And then again, you can use this to forecasting. In 2030, again, this cohort is going to be 20 years older. So it's really sort of going step by step with these cohorts. So let's just summarize again, because it is really a very powerful instrument of social forecasting. I'm not showing this now, but we have applied this to some rather non-demographic issues, such as the spread of a European identity on top of a national identity in the European Union, where there is a very strong cohort component that if young people, like in the early 20s, they have an established identity, and the young ones, to a much higher degree than the old ones, a European identity and not just a national one. We have been used this to forecast that over time there will be more and more people in Europe with a European identity. And actually, despite all the problems of European integration, we've tested this, and this seems to work quite well as a predictive model. So in summary, all populations of human can be meaningfully subdivided into groups whose members differ from each other according to measurable characteristics, which also matter for their behavior. And if membership in these groups is either stable over the life course after a certain age, such as ethnicity or race, they are essentially established at birth, your native language that you learn as a child, your highest educational attainment that you typically finish in your 20s, or, as I said, stable values and identities. These tend to be sort of sticky over the life course. Or alternatively, show patterns of transition that can be modeled based on plausible assumptions, such as marital status transition. There are certain typical ages where people have first marriage, or labor force entry, labor force departure along the life cycle. But you can also look at health status or other things that can change over the life course. But we can have some sort of generalized schedules applied. So combining these both sort of transitions over the life course and intergenerational change, the multidimensional demographic approach allows us to model how societies change over time as a function of the changing relative sizes of these subgroups. Okay, let's come to the second, the demographic theory. That is, of course, very well known. It's 100 years old now. It's the theory of demographic transition. But many authors over time have written that this is not really a theory. It's just a generalization of experience that we have. And here you see sort of a scheme how first the death rates fall and then the birth rates. And then when they have a maximum difference, that is where the rate of natural increase is their highest. And it is, of course, true that many countries experience this in different ways. For instance, the first onset of the fertility decline in France was probably almost the same time as a decline in death rate. Some people even claim it was before a decline in the death rate. And you see societies where this gap is very short between death rate and birth rate decline, others where it's very long and interrupted or whatever. So there is reason to assume that it is not a general pattern. These phases are not typically followed by countries. So what then is the predictive power of demographic transition theory? And I think we can be a bit more modest and say what is certainly important is to focus on the irreversibility. And that is also some important feature. So once fertility has entered, as Ainsley called it, the calculus of conscious choice, meaning that women don't take the number of births as a fatalistic thing. When you ask them how many children you want, Etienne van der Waal has written his PA presidential address about numeracy in fertility. Then if you answer, well, it's as many as God gives me. So there is no planning attitude. It's a rather fatalistic attitude. But then there is this transition to numeracy, to making conscious choices about family size. And this is the whole literature on introduction of family limitation. This then spreads to broad segments of the population. And there's evidence that this is really irreversible. It never has come back in human history in any country to a sort of a uncontrolled pre-transition level. And there are some interesting case studies. For instance, Moldova, a former Soviet republic, now is the poorest country in Europe. And they went through the demographic transition as part of the Soviet Union, fertility decline. And now, I mean, rural Moldovan women are almost as poor as rural African women in, let's say, villages in Kenya. But where in Kenya, the fertility in these rural villages is still 6 or 7 or more children. In Moldova, the TFR declined to 1.2. And even in remote rural areas, it's not above 2. So people, once they've gone through demographic transition, people react differently to poverty, mostly by reacting to postponing birth and still having lower period fertility measures and not going up again. Like you may know, 50 years ago, the Club of Rome had the limits to growth, and they had a model, it was called World 3, where fertility was only a function of income. Well, they projected a big collapse happening right now of our whole economic system. And they then modeled that as a consequence of this, the fertility would go up again to 3, 4, or 5 children per woman. Of course, this is not consistent with the assumption of irreversibility. So that is a predictive element of demographic transition. And the same for mortality. I don't think we will go back, even though we may have big new diseases. I think COVID just reminded us that this is possible. It's not yet out of humanity's progress. There can be even much worse pandemics in the future, but it is irreversible in the sense that the gain in scientific knowledge about the causes of disease and its treatment, that will not be lost. I mean, it was quite impressive how rapidly vaccines against COVID were developed in a time that it's much shorter than ever before in human history. So here is also at least irreversibility in terms of our understanding of the disease. Now, there is a third theory about this. Lots have been written, and I've been thinking quite a while whether it's worth being called a theory, whether it has some predictive power when we talk about the demographic dividend. As you know, the original demographic dividend was primarily related to age structure. Like if fertility declines, there is a higher proportion of people in the so-called working ages than for children and elderly, and this is the possibility of giving a boost to economic growth. Also, there need to be other conditions such as investment in education and health and appropriate institutional incentives. So this has always been qualified. We had a series of articles where we showed that actually it is not necessary to assume that the fertility decline sort of opens up a window. Actually, it turns out that education improvements seem to open up the window. And this is also more optimistic in the future, because the age window will be closing. There's been a lot of writing about the closing, like when aging comes in, then this window of opportunity will disappear. If the window is essentially opened by better education, there is no end of the window, because people can still become more and more productive and better educated. Now, in a more general proposition, and I have many propositions in the theory part of this book, different members of any population are economically productive to different degrees, depending on their labor force participation and their level of education and skills. So it's both the age that matters, of course, working age, but also the skills and the productivity, and an increase in the proportion of more productive people as a proportion of the population increases the potential for economic growth. So this is the predictive power. Question is, can this be falsified? And sort of an increase in the proportion of more educated people contributing to the society leads on average to increases in human well-being in economic and broader terms. I mean, there are some examples, like a country that is quite well educated but has little economic growth is, for instance, Cuba, due to its governance structure and the communist system there. So it is not doing so well in macroeconomic terms, but it's doing very well on other indicators. Like Cuba has high life expectancy, actually higher life expectancy than in the US, which is, of course, many times richer than Cuba. Okay, now let's sort of summarize what we gain by adding education. And I say here, education is the most important source of observable population heterogeneity after age and sex. That we've done lots of sensitivity studies. There are, of course, other sources of population heterogeneity. Some are not observable, but there are other observable ones like ethnicity and so on. But education has such a big impact. And it matters for two quite different reasons, and we have to distinguish between them. The first is almost universally during demographic transition, more educated women have fewer children, have lower child mortality, and more educated adults live longer. I've also in the book written about cognition-driven demographic transition, that is how the education and the abstraction skills associated with education help to accelerate demographic transition. So the changing education composition changes the population forecasts. So even if we are only interested in total population size, explicitly accounting for this source of heterogeneity by age, sex, and level of education produces a different forecast than if we would disregard education, because it's such an important internal determinant. But that is probably not even the most important reason for using education, because education also is a crucial determinant of individual empowerment and human capital. It is a key driver of socioeconomic development, public health, economic growth, quality of institutions and democracy, and adaptive capacity to climate change. So that is why the broader global change research community is really so interested in these scenarios, not only by age and sex, but also by level of education. And as Leben has just mentioned, we've just finished the DIASA conference where the global scenario community was coming together, and they very much valued this input in terms of future human capital and educational attainment projections as a key driver both for climate change mitigation as well as climate change adaptation and adaptive capacity. Now let's again look sort of the, this is Korea now. We just have some animation in 1960. As I said, it's in 1960, really most women above the age of 30 were uneducated. They were also mostly illiterate because when they were young, they had no opportunity to go to school. And then in 1970, you see now the education expansion was there in full swing. You have really the young cohorts much better educated, and you still had very high fertility. Look how broad the pyramid is at the bottom. And then we go in 10-year step. Now, and you see how the better educated young cohorts enter working age and the economy of their country. And this, not coincidentally, is the period when several of these Asian tigers, including Korea, really had this massive economic growth rates. So it is, and using this cohort-specific human capital data, we really could very clearly show that it is indeed the improving education that was the main driver of the rapid growth in East Asia. If you only sort of have indicators like the mean years of schooling of the entire population above age 15, you lose much of the statistical signal, because then you are averaging, let's say, the low education of the elderly population, or the population above age 40 in this case, and mix it with the rather high education of the younger working age groups. And there you get sort of less explanatory power than if you do it age group or cohort wise. And that's where really it became very clear that it is the economic expansion was driven by human capital expansion rather than the other way around, as many economists tend to believe. Yes, it's true that, of course, later, when you expand particularly higher education, you also need the income to build the new schools. But advancing basic education at the beginning is not very expensive, and that is really a prerequisite for the economic growth. Okay, we go on 1990. You see now the fertility gets very low, 2000 and 2010. And now you see Korea is among the best educated countries in the world. For the young cohorts, almost half of the women have already tertiary education. Whereas at the women above age 70, you still see a lot of red. These are still these women who had not had the chance to go to school, but they're moving up the age pyramid and slowly dying, whereas the new generations are different. So here you see really demographic metabolism alive. And then, of course, you can go into the future. And so if we do these multidimensional population projections, it's not really fundamentally different from the general cohort component projections. We just, like, you have a population in year 2000 and want to do it to 2005, you just shift the age pyramid 1 5-year step up. So everybody is 5 years older 5 years later. You have to adjust for mortality and migration. And in this case, then education-specific mortality and education-specific migration. And then you fill the lowest age category, 0 to 4, with the babies born to women. And here again, you just not only apply age-specific fertility rates, but education and age-specific fertility rates. So it's a very straightforward extension of what demographers have always been doing. Now we look at different countries, like here is, for instance, India. We have different scenarios. In the fertility and interaction between fertility and education, we assume different combinations. So here you see only the effect of education. You have the constant enrollment rate scenario. There is no further progress in India. You see still a lot of red there, because until recently, particularly among the women, a large segment of the population were left behind, uneducated, and under this stalled schooling scenario, it will be maintained like this, and the population will increase more. And then you have a fast track scenario that India would do the same what Korea had done in the 60s, and that would sort of greatly enhance the educational attainment of the population and also result to lower total population size. Now, Indonesia, I've just downloaded this from our Wittgenstein Center database, another very big Asian country. In 1950, you see half of the population of Indonesia was in dark red, never been to school, mostly illiterate. And you see just for the younger cohorts, some basic schooling has started. And here again, we go 1960, 70, 80. You now see how the younger cohorts are improving. They are not improving as rapidly as we've seen for Korea, where then everybody was already educated in the 1980s. So there is more gradual progress, as many other countries in Southeast Asia have done it, and now starting to do in Africa. But still progress is visibly seen in the 1990s. Some blue is added, so more secondary education, 2010 and 2020 now. Indonesia has even sizable male and female populations with post-secondary or tertiary education. But still, you see, particularly among the older cohorts, still some dark red. And then we can just go into the future. This is the medium scenario, Indonesia for 2030. And you have then a rapid development scenario where really they are speeding up education expansion. And then you get a population pyramid that is possibly already looking like Korea today, but some decades in the future. And then we also have the long term from 1950 to 2100, according to the medium scenario, where Indonesia will expand, continue its education expansion and peak around a little more than 300 million. If the stalled development, there will be much less educated, and that Indonesia will grow to over 350 million, but with much lower human capital. And then there's the very rapid development scenario, the SSP1, as we call them, in the shared socioeconomic pathways. You have an earlier peak, and you have a much better educated and also more robust, most likely more healthy, richer society with higher adaptive capacity to climate change, which is already unavoidable. Nigeria is an even more extreme case between this rapid development, because Nigeria still has much higher fertility today, and sort of there, in the case of stalled progress, you see that it could grow up to almost 1 billion, one of the biggest countries in the world, and you see actually an expansion of the uneducated under the stalled development scenario, because there still are uneducated people in large segments now, and this proportion through high fertility would actually increase if schooling doesn't expand. You find all these scenarios for all countries in the world from 1950 to 2100 on our Wittgenstein Center Human Capital Explorer. So you can get the data, and you can get these moving edge pyramids. And so if you're interested in looking at your country, please do so. Now, time is running, and we have to go a bit ahead now. How does this affect global population outlook? We've seen that in all the countries in demographic transition, and here you have all the DHS countries sorted by the average level of fertility here on the x-axis, that even if we have a very detailed 6-category educational breakdown, you see that consistently those women with no education have the highest fertility rates, and those with the higher education have lower. Now, that's the way we implement this in our scenarios for all countries. So we have a future path of these 6 education categories of TFR here. So like in the case of Kenya, empirical data for 2010, it shows that women without education have more than 6 children, and then the most highly educated have just about 2. And now the green line here, that is the weighted average of education-specific fertility rates. Now, if education stalls and you have a lot of women in the uneducated category, then the green line giving the weighted average will be higher, so the overall fertility of the country will be higher. If you have a massive expansion of education, like we've seen in Korea in the future, then the green line will be lower, and that is sort of the outcome of these given future education trends, but a variable so future fertility trends, but a variable education. So there was a review article in this journal Science that illustrated this quite dramatically with different education scenarios, strongly contrasting. So we took the identical education-specific fertility trends and then had a pessimistic education scenario, no new schools being built at constant enrollment numbers. And you see this was already starting in 2000, that by 2050, the world population under this scenario would have increased to 10 billion. And then you have the other extreme, doing a fast track expansion like we had seen it in Korea or Singapore. And then only because of the education difference, with assuming identical education-specific fertility, here the world population would be much lower, already below 9. So the education is indeed a very powerful driver. Now let's come to mortality. There we have the same story. You may know this Preston curve, which was very famous, and economists still refer to it today. Also, it was published in 1975 already, showing at that time by data for the 1930s and 1960s that you have national income on the one axis and life expectancy on the other. Yes, with higher income, life expectancy quickly increases, but then it flattens. So at a higher level of income, it doesn't buy you more life expectancy. And also there is a shift over time. So the same income level is associated with higher life expectancy in the 60s. And Preston and others attributed this to medical progress, public health progress, so that there's sort of a secular improvement outside. Well, we've recently revisited this in another paper in Population and Development Review with data from the 1970s, 90s, and 2010 that you see on the right-hand side. And here we essentially see the same picture that Preston found in 75. You see this diminishing returns, this flattening of the curve, and also an unexplained shift over time moving upward. So that seems to reconfirm the insight of the Preston curve that economists still refer to all the time. But if you now, instead of GDP per capita, put the mean years of schooling, the educational attainment on the x-axis, which you see on the left-hand side, then you see a very different picture. You see an almost straight line, means there is less of a diminishing return, so showing that some higher education, still even at the high end, can buy you more life expectancy. And importantly, there is no unexplained shift over time. So in many respects, education explains the progress in national level life expectancy much better than income. In this paper, we went deeply into the causal analysis because, as many people point out rightly, there is really an interaction going on between income, health, and education. And many of the economists think this is endogenous. You really cannot sort it out. And so our hypothesis is that the apparent correlation between better health and higher income is not the one influencing the other, but it is could also be a spurious correlation in the sense that better educational attainment is influencing both. It's leading to higher income and to better health and longer life expectancy. How can we sort this out? Well, here we can benefit from the huge time lag that I just showed you. If, let's say, 70-year-old adults are in better health status, as I will just show you in a minute, this cannot be endogenous due to their currently better higher income or other current factors, because this education they received 50 years in the past, and so their current conditions cannot influence the education that the cohort received early in life. So by explicitly looking at this time lag, we can really sort out the difficult causal issues. So we summarize this in a policy brief that when it comes to survival, mind matters more than money. This is just Austrian data, as I mentioned. Also, these are disability rates, the limitations to activities in daily life. By age, of course, it increases with age, and that's why everybody is scared that in an aging population, we will have a rapid increase in disability. But what you see here actually is good news, because you see that let's look, for instance, 80-year-old women here. If they only have the lowest education, the Pflichtschule here, that is the red one, they are twice as likely to be disabled than women with some degree of university education. And since we know for sure that the future elderly will be better educated than today's elderly, this gives a more optimistic picture that these more educated elderly in the future actually will be, on average, at a given age, in a better health status than today's women in the same age group. Now let's move to labor force participation rate, another economically very important factor. Also here we see this is for all the EU countries together, that the more highly educated, these are the dark blue, are having a clearly higher labor force participation. We're looking at women here than the less educated. Now, this brings me to another paper that is, I think, quite influential and has already been cited, and really changes the view, we should look at population aging. This is with Guillaume Marois, who I think is also online. He's working at ADRI. We published this in PNAS, the Proceedings of the US National Academy of Sciences, where we were using microsimulation, but the same kind of multidimensional approach, comparing for all European countries how different scenarios, including explicitly not only education, but also labor force participation, would result in an economic burden. And here we see two quite different countries in the European Union. Is Sweden. You see now the color gives you whether women in this case are in the labor force, and the shading gives you their level of education. So you see in Sweden, the green is sort of most men and women are in the labor force, and there's a high proportion with dark green, which meaning the highest education category. And then, of course, above the age of 65, there are still some men and women in the labor force, but mostly they are out of the labor force. Italy on the right-hand side looks quite different because their female labor force participation is clearly lower. You see sort of after the age of 40 for the cohort, there is clearly a lower proportion being in the labor force, and the education level of those in the labor force is lower. So well, given this, we now see like how should we study in demographic terms the dependency burden. And as you know, most demographers still these days use a very simplistic and in my view even misleading ratio, the so-called age dependency ratio, which simply takes the population sorry, of people above the age of 65 and below the age of 20 to the population in the so-called working ages, although not everybody in those ages actually works. So it's a very poor approximation without any labor force or even the productivity of the labor force. But this green line, as you see it here, it's the conventional age dependency ratio, increases very rapidly by 60% here to 2060 in the European Union. And that makes, of course, politicians nervous. That's why they have all these aging reports coming and so on. But already if you calculate the much more meaningful labor force dependency ratio, so you're taking the people who are not in the labor force to those who are in the labor force, and then you see a much lower increase because of labor force participation. We've seen something this for Italy, that the younger cohorts of women are to a higher extent in the labor force. So the future looks less negative if we factor in labor force. And then the blue line, in addition, covers the productivity weighted dependency ratio. So we don't only distinguish who is in the labor force and who not, but also what is the education level of those in the labor force, with the more educated being more productive. And as economists usually do, we measure productivity through income differences. So through the education income differences. And since the young cohorts are better educated than the older ones in virtually every country, you see that here even the burden is increasing much less, only about 10% if we take this productivity weighted dependency ratio. And now in this paper, we also combine this with different migration scenarios. So here you see the blue line again. On the top, the solid blue line is the productivity weighted labor force dependency ratio. And then we see like what happens, the solid red line, is we combine this with a Canadian type migration policy. As you know, Canada lets in many migrants, but is selective. They only choose more highly educated migrants. Well, if the European countries would have such a policy, then you see a flat line. There's no change in the economic burden. And then actually the dotted lines show that you can still be doing better. If you combine, let's say, the Canadian immigration scheme with the Swedish labor force participation, assuming that over the next 15 years, sort of all women in the European Union, in the other countries, like including Italy, would work as much as Swedish women already work today, then actually we would be doing better. There would be a 20% decline. This is the dotted red line here. So this really shows that both immigration and the education composition of the immigrants, as well as labor force participation of the domestic population, matter greatly. And the top line here is actually interesting, that has a Canadian migration volume, but of low educated migrants and low integration, like we see it in Italy these days. So even this larger number of migrants would lead to a higher economic burden, because these migrants are not integrated in the labor force and less productive. So this discussion whether Europe needs migrants for demographic reasons really needs to be looked in a more differentiated way. It depends who are these migrants and what is the labor force participation. But overall, this picture clearly shows that the future is not as bad as often people think. That demographic change really is a major threat to our societies if we have the right policies. Now, finally, we did a similar paper on China, published late last year, also with Guillaume in the lead, and colleague Stuart Baston and myself. That was when the information came out that China has a lower than expected fertility. It's somewhere between 1.2 and 1.3, I assume, at the moment. Yeah, of course, there's a big discussion. What is the actual level? And many commentators in newspapers around the world wrote, wow, this is very bad for China's future. They will possibly not catch up with the US in economic terms because of their low fertility. Well, this makes no demographic and no economic sense, this reasoning. Even if we take the old-fashioned conventional age dependency ratio, you see here the two solid lines. We have playing with scenarios, one that the fertility in China would decline to 0.8, a very low level, but we see it in South Korea these days. That's the current Korean level. And the other, the solid red line, shows that they would increase by about half a child to 1.7, the TFR. Well, if you compare the the age dependency ratios, the total age dependency ratios here, you see that actually the green line, the low fertility, would be advantageous for the coming decades because there is lower child dependency. It would only be after 2050 that the two lines cross, and then the low fertility would impact on a higher age burden. But over the next 25 to 30 years, I mean, that's where much of the action will happen, and that where China will likely surpass the US as the biggest economy in the world. And for that, actually, low fertility would be a booster rather than a break. But as I said before, it's not a very meaningful measure to look at this age dependency ratio. Here again, we have the labor force dependency and the productivity weighted labor force dependency. These are these dotted lines. And here you see that even there, under this productivity weighted ladder, the dotted green line would actually show a decline in the dependency over the coming decades with very low fertility. But the difference between the red and the green is not very big. And overall, quite independently of education, quite independently of fertility, there would not be very much of an increase in the economic burden. So here, aging in China looks much less daunting than many commentators pointed. And the main reason is that the young generation in China today is so much better educated than the older generation. This recent education expansion will, in a way, offset their population aging. That's at least what these ratios show. Okay, we slowly should sort of move to the last part. Again, just summarizing, what is the education effect? Why does education have such a big influence? And in the book, I write about functional causality, which is in the social sciences, a concept that is a little different from the natural sciences. And also, the education is not just assigning some labels to people. It is not just a proxy for socioeconomic change, but education really changes our minds, our brains. And I often refer to Eric Kandel, where he was Vienna born, but then migrated to the US, and he got the Nobel Prize for medicine in the year 2000, yes, for his work on the human brain and on learning. And he very clearly points out that every learning experience, and particularly once it's repeated, it builds new synaptic structures in our brains that are stable and will stay there for the rest of our life. So he sometimes said that if you will repeat this, we have this insight in our brains, and now when you walk out through the door, you are physically a different person than when you entered, and you will stay so for the rest of your life. So I say this because education really changes not only our mind, but our body, if you want, in this sense. It enhances cognitive skills. We talked already about the calculus of conscious choice. It changes to less risky behavior. We have a longer planning horizon. We are faster in learning from past damage. And of course, we have better access to relevant information and typically also higher income resulting from these better skills. So there are many avenues to which education matters for our demographic behavior, for our economic behavior, but also for our adaptation to climate change. And that is my last point now, like how it matters for sustainable development. Here you see the chart, how the human population causes climate change on the left-hand side through energy consumption, greenhouse gas emissions, but it's also us, the human population, who has to come up with behavioral change and greener technologies, inventing new greener technologies that can help to mitigate climate change. That's the word used to reduce. There is already climate change going on, but the question whether we are heading for 2 degrees or 3 degrees or possibly even more, that depends on our mitigative behavior, reducing ongoing change. But almost equally important, and that's where the emphasis was really put in, is our adaptation capacities. How will the climate change on the future affect the well-being of the human population in the future? How will it affect the mortality? And indirectly through the livelihoods, then also the migration of human populations. And here it is very important to see that the climate of the future, you see here climate at time t plus x, will not meet the population of today at time t, but we need to forecast the human society, the population, also for the year t plus x, because that is the population that will have to cope with the climate of the future. So that's why these multidimensional demographic scenarios are so important for assessing how dangerous will climate change be for future human well-being. And as we've discussed in ADRI and this big scenario forum, there is this broadly shared framework of the shared socioeconomic pathways, SSPs, that sort of classifies here socioeconomic challenges for mitigation and for adaptation, and depending on which corner of this you are, you have different scenarios. In demography, we mostly look at the SSP 1, 2, and 3, which is sort of rapid development, middle of the road, medium, and stalled development. Here you saw the results for world population growth. Actually, these days we are just coming up with a new assessment, which is not yet finalized, so I can't show it yet here. But essentially, you see that with the SSP1, the rapid development, the world population would already peak around mid-century and then decline and be much, much better educated. The middle of the road scenario would see the world population peaking slightly below 10 billion and sort of show an intermediate improvement in education. But if the world is educational expansion and other development are stalled, we may see a world of more than 13 billion and no significant progress in education. So this population, this world will be much more vulnerable to already unavoidable climate change. Now, I had one of these ERC projects completed some time ago on the effect of education on differential vulnerability, and we have many case studies put together. What I learned here is that it's really important to have a variable on the table as a possible candidate, because in the risk and disaster research community, they studied all kinds of determinants, but not so much education. I mean, actually, with this grant, I paid a young scholar to the dissertation on the effect of Hurricane Mitch in Central America, and they visited households and they looked at the income of the household, they looked at how the house was constructed and tried to identify what are the main risk factors. But they did not even ask for the education of anybody in the household. So I paid them to go back and ask the education to the same households. And to me, not surprisingly, but for them, for the big surprise, education turned out to be the single most important determinant of vulnerability or resilience. But if they don't collect data on education, education can never come out as the key driver. So you really need to have the right research question and the right variables on the table in order to produce meaningful analysis. And we've done like how education matters from pre-disaster awareness to the understanding the warnings and doing better during the disaster, being less vulnerable and recover more quickly after the disaster. And we summarized this in another piece of science with the title Universal Education is Key to Enhanced Climate Adaptation. And Science magazine put the subtitle there, Fund More Educators Rather Than Just Engineers. And I had many angry calls from engineers that didn't like this, but at the moment, all the money is going to engineers. You may have heard about the Green Climate Fund that has now pledged in Paris and the subsequent climate conferences. That's $100 billion per year. So that is quite sizable money. And where's the money going? Well, it's at the moment all going to infrastructure projects, essentially sea walls and some very concrete things. And our point is that maybe some of this money would be better invested in educating the people, enhancing their capabilities to flexibly react to whatever the climate of the future will be. And I mean, through that, if we hadn't done this education-specific analysis, we wouldn't have come up with this highly policy-relevant conclusion. Okay, finally, there are these sustainable development goals. Some of them affect population. We had another paper in PNAS here with Guy Abel, also who is at the ADRI, seeing how the outlook for the world population would be lower. This is sort of this blue shaded area is lower if the SDGs were implemented sort of as a turbo for development between 2015 and 2030. And yeah, this also shows that there will be impacts of the SDGs on demography. But now we are also looking at how global environmental change, the other SDGs, impacting on human well-being. I happen Sustainable Development Report 2019, commissioned by the UN General Assembly. And there the problem is that there are already 169 targets of the SDGs on top of the 17 goals, and then there are more than 210 indicators. So often you don't see the big picture for the many small indicators. And so my recent work has been focusing really on what in sustainability science is called a well-being production function, where you have a W, human well-being on the left-hand side, being explained as a function of all kinds of capitals. This is natural capital, manufactured capital, human capital, institutions and knowledge. So trying to understand, and there has been a lot of literature on this, on the inclusive wealth on the right-hand side. But very few people try to find clear-cut indicators for W, for the well-being on the left-hand side. And we've been proposing here with colleagues a new indicator, a tailor-made indicator for the study of sustainable development that we call years of good life. And I showed it because it's a very demographic indicator. It's in a way like healthy life expectancy. I mean, the gray area here is overall life expectancy. And that's important because being alive is a basic prerequisite for enjoying any quality of life. I mean, that is so evident, but still many other well-being indicators don't have the length of life explicitly factored in. But surviving is typically not considered good enough. So you want to survive either according to good subjective quality of life conditions or objective ones. So the subjective is like happiness and life satisfaction. And so we defined a year is only counted as a good year of life if you are above a certain minimum level in your subjective life satisfaction. But you also need to meet a certain objective criteria like being out of absolute poverty and being free from physical and cognitive limitations. So if you are doing okay above a minimum level, both on the objective and on the subjective, then the years of life are counted as years of good life. And we've calculated this in the team for many countries around the world and also reconstructed. And here you just show for 3 countries how the YOGL, the years of good life, that's at the bottom, has been improving for women in these 3 countries. But due to quite different underlying factors, for instance, South Africa, also life expectancy, the gray line, declined a little, overall life expectancy due to AIDS. On many of the other accounts, the population was improving. That's why the years of good life on average increased here. This is just an outlook that demography can also come in here and play a very important role, in particular this multidimensional demography. In terms of seeing what is the ultimate end, what is the goal of development. So we are both important for understanding the drivers and the outcomes of development. Okay, I'm concluding with just pointing at a new development here in Vienna, where we've now at the University of Vienna, in addition to the already existing pillars of the Wittgenstein Center, the YASA population program, it's now called Population and Just Societies, then the Vienna Institute of Demography of the Academy of Sciences. Most recently, the University of Vienna has opened a separate department of demography. We offer a doctoral school in demography and also now an English language master science program, Master of Science in Global Demography. We actually just last week accepted 40 new students to this. So everybody is encouraged to also apply to this English language program that will also try to cover some of the things I've shared with you today. And finally, we don't have time now, but this, of course, also shows that our population policy paradigm that we should use now based on this multidimensional approach is not just to try to increase the fertility rate or what other sort of demographic engineering, but it is national human resource management. We need to look at the productivity, the labor force participation, and all these things that in a company, in big companies, you always have human research managers. I think a population policy should be at the national level, make sure that our countries have good human resources for coping with the many challenges of the futures. I stop here and thank for your attention. You are still muted. You're muted.
Thank you, Wolfgang. This is fantastic. And thank you for the scientific wisdom and enlightenment. Your theories, your understanding of demographic theory and the introduction to the methods has already inspired many younger generation of demographers, our students in their studies and pursuit of scientific research. Now, with that, we open the floor for questions. If you have any question, just unmute yourself, or you can raise your hand, your electronic hand, and we can see you, or you just like unmute yourself directly. Professor Ren Yuan, I see your hand. Please unmute yourself.
Okay, thank you, Professor Lutz, for your ground view of your talk on the population development, and thanks, Lei Wen, for provide such a good opportunity for us. And one thinking is I'm also one scholar inspired by you. And you read a lot of your famous good works. And one a question was, is you mentioned the multi-dimensional population projects with especially with the dimension of education. And I have thinking that the education is to some extent different with sex and age. Sex and age is more fixed, but education is to some extent more flexible. For example, the education one education year in China and in the US might be different, and so how we have some saying that although people's education years are increasing, but the people's knowledge and wisdom might not be the same. Maybe the university level, college level student now might be similar as a high school education level in the 1970s. So when we use this education based comparative studies among countries, and do you think how to solve this kind of limitation?
Well, thank you very much for this important point. It's indeed a very relevant question. And in the book, I also write about this because, yeah, for good reasons, as you just said, many people believe that sort of sex and age, they are sort of biologically given things, whereas education is more a social construction. And to some extent, it is still true. And there's nothing wrong with also sort of modeling by social constructions, but increasingly we understand that all three have both elements of social construction. And so age, I sometimes say age is not what it used to be. You may have heard of the work of my colleague Sergei Sherbov, who sort of had a project on redefining age and aging, saying that as life expectancy increases and people are longer in a good health, sort of 70 becomes the new 60, or I've actually proposed once that as life expectancy increases, like in Austria, for about 3 months every year, it's a very rapid increase. Maybe we should only celebrate our birthday every 15th month and not every 12 months, and then we have a different age. So in that sense, like age has been put into perspective. It's not just the absolute given. If we look at the, yes, the chronological age is given, but our biological or cognitive or whatever age changes. The same is with sex, and then, you know, even the Austrian government has now officially introduced not just 2 categories, but people can choose among 4 categories with which gender they have. And also here, in many country after country, it's not so clear what is the biological given here. So I'm saying this because in education, we also understand that it has a strong element of social construction, yes. But as I said, with reference to the brain research, it's also that education also changes our body. So it also, we understand it has a biological component. So this is sort of a quick answer. And then, of course, when we look at education, what we should try to distinguish is the content of the education and the quality of education, which are more variable, from some very basic features, some basic cognitive empowerment. And of course, this difference is particularly strong when we go from being illiterate, where it's also been shown that we just have lower abstraction skills if people never learned how to read and write and have no numeracy, to be having some basic literacy and some basic numeracy. So I think this is the most important for kickstart development. And the higher we go with the education, the more important then becomes the role of what are we exactly teaching and what is the quality there. So yes, there's much more work to be done, but it's interesting that even if we have these very crude categories, let's say 4 very broad formal educational attainment, because that's where we have the data in many surveys or censuses. They do not test the quality, they just ask what kind of school have you completed. Even then we see these very big differentials and this very big impact. But this is clearly only a beginning. We should do much more analysis.
Thank you.
Thank you.
I see a lot of hand. Matthew Talkamy, could you please unmute yourself, and could you please also, when you ask a question, before you ask, could you also introduce yourself, identify your institution?
Yes, my name is Mateusz Łakomy. I'm from Poland, and I am advisor to the Deputy Minister of Family, Government Plenipotentiary for Demographic Policy. So we're working on demographic strategy that probably Professor Lutz might have heard about. My question, it was very interesting lecture. What struck me, it was this part of the lecture that you said that low fertility or even very low fertility under some circumstances in mid-term perspective, like a few decades, may be beneficial. But if we take like a very long perspective, secular perspective, in the long run, this low fertility may lead, well, ultimately to the extinction of the population, to put it like more straightforwardly. Wouldn't then the benefits of the low fertility like diminish, and how this secular perspective might change the perspective you presented? Thank you.
Thank you. This is also, again, a very pertinent question. Now, a time horizon really always plays a role. And as you may know, economists usually, they don't like to talk too much about the very long, because they discount it away. It depends what discount rate you apply. And also there's a reason we don't know what will be the technological change over the coming decades. And what I want to rule out is really the extinction of the human species. I mean, we did some long-term, we have a paper actually about long-range population forecast to 2200, 2300. And there it's like, if you assume that let's say the whole world will converge to a 1.5 TFR, that's our average we have in Europe at the moment, then by 2200, the world population would be somewhere between 3 and 5 billion, depending on how high life expectancy increases. Like if life expectancy stops at 90 for all countries, then will be about 3 billion. But this is what the world population was in the 60s. That's what I learned in school, and we were doing quite well there. So, and then of course there are some adjustment processes. Of course, fertility will not permanently be at a very low level, or we at least don't know, but I don't think it makes much sense to go beyond the current century. And there it's what I try to show, and this is sort of pure arithmetic, that if you take just the standard age dependency ratio, that where dependent are both the children and the people above a certain pension age, then if you lower the fertility, at least for some decades, until these these youngsters enter the labor force, which these days is relatively late, and many of them, if they have better education, only in their mid-20s, enter the labor force. So for these 25 years from now being fewer babies born, actually society saves money for the young dependency ratio. And that can be used. It can be used for all other good things. Of course, hopefully it will also be used to improve the education of this fewer number of people. So that is often forgotten when people talk about low fertility. Oh, this is a national disaster. There still is some sort of a nationalistic thinking about it, that still in the end, every country wants to have more people than the neighboring countries. This is a sort of a very deep-seating idea about derived from the history. The history always, demographic decline was a consequence of disasters like famines, wars. Now, at this time, people tend to reverse the causality and think that also demographic decline for benign reasons, for voluntary family limitation, would reside in disaster. And I don't think so. And we've also talked about the environmental perspective, like from a climate change perspective, biodiversity perspective. Lower population size is actually highly desirable. It will help to improve the quality of life of the people. And some time ago, I was asked to write about this in the Royal Statistical Journal of the UK, asked me to write an editorial, and I gave it the title based on these long-range projections that I just had mentioned. It says, towards a world of 2 to 4 billion highly educated and therefore healthy and wealthy people who will be better able to cope with already unavoidable climate change. It's a long title, but it shows sort of the optimistic picture of the future if we go for this path.
Yeah, thank you, Wolfgang. There are lots of questions raised in the chat, and one of this is from Murali Volapuran, asked that knowledge alone is not adequate to bring a change in the behavior. Some examples, but until you put a tax policy there, so that can trigger the changes. How do you comment on that?
I'm not sure I fully understood the question. What policies are we talking about? Environmental policies or?
Environmental policies. And we know that plastic bags are not good for the environment, and people won't change the behavior until you impose some tax.
Yeah, well, this is an important issue, of course. Taxes, policies can influence behavior, that's for sure. The question is how should governments, particularly in a democratic context, national governments only impose, let's say, a carbon tax on energy if the majority of the population backs this. And that is why, again, the education of the entire population is so important. If, let's say, 60–70% of the population don't understand what is climate change, they don't really know what is CO2 emissions, you can't smell it, you can't see it. That requires some abstract thinking skills to understand the danger of climate change. And unless the population is educated enough to understand collectively, at least in a majority, this threat, they will not vote for a government that does anything to reduce climate change. So that is another way that why indeed we need to enhance this cognitive ability of broad segments of the population to also engage in these mitigative activities.
Yeah, we are actually running out of the time, but I still want to, maybe we can go a little beyond 1:30 or 1.5 hours. And there's a question from Sri Lanka, Susan Parara, asking, in Sri Lanka, there is some evidence increasing level of education does not have much effect on female labor force participation and economic growth. How do you comment on that?
Yes, this is another very important issue. Of course, the education enhances the cognitive ability of people. There is no doubt about this, at least if it's education of a reasonable high quality. However, how this translates into the choices of joining the labor market or not, that depends very much on the cultural context. And indeed, there is evidence also in India that the more educated women now can afford to stay home as housewives. This is sort of it's a status issue that once they come out of a working class context where they are obliged to work very hard in a low qualified job just for survival, as soon as they can afford, or they have husbands who are earning enough so they don't have to work. This is the same thing that we observed in Europe in the 1960s. That, I mean, in the 1960s, women were also getting much higher educated, but female labor force participation was very low because there were these social norms of the bourgeois family and so on. But it went away. I mean, this was a cultural evolution. Now, these days, all the essentially higher educated women all want to work because they want to have their own self-fulfilling life, their own purpose in life. So my answer is that yes, particularly on the Indian subcontinent, and I assume in Sri Lanka it's not so different, you see this current phenomenon of more educated women actually withdrawing from the labor market. But my strong assumption would be that this is a transitory phenomenon based on what we've seen in other countries.
Okay, thank you. While I continue to read the questions from chat, if you have any of you have any other question, you just raise your hand or unmute yourself. There are several questions from ADRI colleagues. One from Samir and ask, if all being equal, high income household individual will enable people to choose better health care, maybe will lead to better health consequences. And yeah, so that's the relationship between education and income. Right?
Yeah, of course, they are very closely related, because typically more educated people have the potential to earn more money. But it depends also on what your values are. I mean, you have causation both. If you are educated, you are clearly empowered to help yourself better and help others better. That's the way I sometimes put it. But if you only have money and don't have wisdom, you may do the wrong things with your money. I mean, there are many studies about people who win in the lottery. They're often low educated people who all of a sudden make millions in the lottery. And then there's a book has been documenting how they actually become less happy than before. They do all kinds of stupid things with their money. And so that's why I said the mindset, what you want to do with your life and what is your strategy, is more important than just having the cash. Of course, without the money, sometimes without having any money and have enough to eat, you also are in problem. But typically people who have some basic empowerment, they at least, unless there's a national disaster of some sort, will have enough to eat. And so there is clear sort of the causation wherever we look, that can be more clearly identified from the education to the income.
My colleague Chen Chen also asked, does the kind of education matter, and how you measure education, year of schooling, if a year of schooling or a certain degree is more effective in affecting population dynamics in some countries than others, how you measure education across countries.
Yes, but I mean, I actually had a few slides that I dropped and that addressed this question of measurement of education, because the time was already too long for this lecture. I mean, the easiest way is that, as you showed, like have 4 or 6 educational attainment categories as they are given by UNESCO, by the ISCAT categories. And for these, we then can also see what are the fertility and mortality levels associated with them. But it's of course true that these categories are associated with different levels of skills and actual knowledge in different school systems. So within countries, there are good and bad schools, and across countries, we have quite some differences. So we've recently started, and also we had another PNAS article on this last year about the growing gap in skills. So there are some surveys both in schools, the PISA tests at the age of 15 typically, but we also have adult literacy surveys that the OECD does, where different adults at different ages are given a card with some text to read, and then it's tested whether they can understand what's in this. We use these literacy skill tests to adjust the education categories, or to adjust the mean years of schooling by skills levels. And it shows up that unfortunately in the world, we really see a growing gap in skills. While some of the developing countries in Africa, they have made great efforts to expand universal primary education, which is a good thing. And they were asked to do this by the Millennium Development Goals. But unfortunately, some of this expansion has come at the expense of quality, so that the skills for those who went through school are really lower now than they had been when they had a more restricted school system. So this is clearly something to work on. And then I said it's the quality of education, and then the content, whether people get more technical education or more liberal arts education. That is all a big discussion. And yeah, we should have this discussion, and demographers should contribute to the discussion, because so far demographers have not been part of this discussion, and we can contribute a lot.
Thank you. I also have a lot of questions to ask, but I think I can refrain from asking right now. One thing I was just thinking, for measuring demographic metabolism. So we can think about from the temporal and the spatial scale. in a way like with the population aging, increased life expectancy, the replacement level, generation replacement level will change. And also the driving forces of the replacement can also differ across scales between different regions. And in the small, some depends on where you measure this. In some smaller scale, and migration rather than fertility or mortality could play an even more important role. Yeah. So that's something that a set of methods are. How do you consider the methods can be used to measure to study the demographic metabolism?
Yeah. Well, I think this is it's a very broad concept, the demographic metabolism, and you just rightly said migration is also a very important mechanism. I mean, just think of the big global historical changes like the conquest of the Spanish of Central America. This was a migration movement that, together with high mortality of the indigenous population, the Aztec, there essentially disappeared. It was absolutely massive cultural change that happened through population replacement, new people with different culture taking over, partly through to migration and partly through to very high mortality due to the infectious diseases and the influenza that the Spaniards brought. And then, of course, there was a new generation then coming with some mestizos. So it's a really sort of, I think much of human history can also be explained in terms of this demographic metabolism.
Thank you. We are 7 minutes over the time, and I'm conscious about this is the end of the working day for a lot of Asian colleagues and students. We are wrapping up. Thank you again, Professor Lutz, for the very enlightening seminar, very comprehensive, very educational. As always, we always learn new things from you every time when we listen to you. And thank you again. And I also want to say that over the past years, due to the pandemic, some of the events we hosted at Asian Demography Research Institute, new headquarters of Asian MetaCentre, has been stopped, very unfortunately. But when the pandemic is over, then we will resume some of the events and joint research projects and workshops and also seminars gradually. And we are looking forward to see more often than the past years, you in person or virtually. And thank you again for coming to the joint seminar. And I'll see you next time. Thank you, Wolfgang.
Thank you very much for your attention and all the best to Asia.
Thank you all.